This meeting is being recorded.
Welcome everyone to our 3Q quarterly COBOL Programming Course webinar. This time we have a special guest, a couple of special guests, Reg Harbeck, who is an IBM Z champion and also a member of our sister project, COBOL Working Group here at the Open Mainframe project. We look forward to a conversation with you, Reg, in a moment. And also our student mentee, Sainath Rao, who's been working on updating our COBOL programming course through the Summer Mentorship program. So without further ado, what I'd like to do is go around the virtual table and do a quick round of introductions. Myself, I'm Sudarshana Srinivasan. I work for IBM as an IBM Z Systems Advocacy Program Manager. Thoroughly enjoy my role of working with the community and really talking about the importance and the role of IBM Z out there and really bringing on that next generation of technologists onto the platform. And I'm also a co-chair of our COBOL programming course at the Open Mainframe project, along with my partner in crime, Mike Bauer. You're here, so I'm going to point that way. Mike, take it away.
All right, thank you. I'm Michael Bauer. I've been involved in the mainframe space for about 8 years in various roles. Started as a software engineer, transitioned to a product owner, and now I'm a product manager focused on various DevOps solutions within Broadcom. But I've also been heavily involved in the open source community, whether that's part of the Zoe initiative or as part of this COBOL programming course. And with that, I'll turn it over to Hartanto.
My name is Hartanto. Unlike Mike, I've been around for only 2 years. I'm still a student from Singapore, and I'm now a committer for the course. And with that, over to you, Joe.
Cool, so I'm struggling for my unmute button. Yeah, so my name is Joe Winchester, and I am in England, which is in the United Kingdom and used to be in Europe, but don't start me on that conversation because we won't finish. So very happy to be here. I work on I love open source and I love the mainframe. So I double squared love the Open Mainframe project because it's a union of the two. And the project I spend most of my time with is called Zoe. That's it. Hey, Paul, how about you?
Yeah, so I helped get the COBOL courses started. I seeded it with some simple code and I take care of the back-end system. And I'm grateful that Mike is there to manage the GitHub because I'm still scared of GitHub. I just see collisions. And but basically that's me. And so I'll turn it over to Sainath, if I pronounce that right, and help me with that pronunciation. Is it Sainath?
Yeah, Sainath, you got that, Paul. Sainath, go ahead, introduce yourself.
Hello, this is Sainath Rao from IIT Roorkee. I have been doing since 3 months, I guess, as a student mentee for updating the course, and I have gone through.
All right, Reg, if you want to go ahead, introduce yourself, and then share with us what the COBOL Working Group worked on. I know there was a survey that was done, and we're really curious to learn about those results and how that could help us further drive. So take it away, Reg.
Thank you very much, Sudarshana. So my name is Reg Harbeck, and one of the things that I've been involved in recently is the Open Mainframe Project COBOL Working Group. And so let me just use this PowerPoint as sort of a basis for telling you about what we are and what we've been up to. So I'll start by just kind of introducing myself and the COBOL Working Group and stuff like that. Then just take a look at some of the issues. COBOL still alive, and what's the role of COBOL in the world today? Does it still matter? How much is out there? What lies ahead? And then take a look specifically at the survey and what we found and some of the further steps to moving forward. I like this cartoon here, just sort of a little reminder of what we're going to talk about, that the role of COBOL is really not trivial, shall we say. So we can see the genie says 3 rules: no wishing for death, no falling in love, and no bringing back the dead. And so the person says, I wish to rewrite all our COBOL code into Java. And that's 4 rules. The role of COBOL in the world is so amazing, and I'm going to talk about that shortly. But let's just quickly tell you about myself. So my name is Reg Harbeck. I started working on computers actually before I started my computer science degree, so probably 1981, got my computer science degree in 1986. I wrote my first COBOL program in 1985, and then subsequently took my first COBOL course. I've been an IBM champion for, as I like to say in Canada, Z, since 2020. In 2021, I got my Master of Arts degree with a focus on the humanity of the mainframe. Also recently published a mainframe textbook with Dr. Cameron Say, who is the fellow in charge of the COBOL working group, and Carl Eric Stemfors and David Boyes. And so I'm just basically a very active mainframe nerd with a lot of COBOL background. So specifically, the COBOL working group was established to really get a good understanding of and then communicate the whole role of the COBOL in the world of business, among other things. And that's one of the things to keep in mind about COBOL. You know, I like to joke that one of the reasons that IBM and COBOL go together so well is they have the same middle name, B, business. You know, common business-oriented language. So as we take a look at COBOL and really started to dig in our project about, you know, what was COBOL and what did we need to find out about it and share, one of the things that became really evident even before we really had done a lot of in-depth surveying was that the COBOL programs run systems of record for the world economy. Now, what's interesting is, you know, I talk about IBM, and IBM mainframes are not even a little bit the only place that COBOL runs. But let's be honest, IBM mainframes and COBOL go together remarkably well. And as I'll talk about shortly, you know, COBOL itself has actually been around since before the IBM mainframe. But certainly the IBM mainframe is in many ways a system of record for the world economy. But COBOL programs likewise are system of record programs for the world economy. And you know, one of the reasons for this is that COBOL was written to be such a language. It was written for business-oriented processing, including, among other things, the fact that it does decimal math natively. So you don't have to be converting between binary and decimal and then have loss of data, which is a major problem when that data is financial data. So COBOL then applications support banking, insurance, transportation, government, retail, healthcare, and many other sectors. And as we'll see, there's just a fairly vast amount of COBOL. And here's the thing, COBOL and the IBM mainframe have many things in common. One of those things is that they were designed to allow you to not have to keep writing stuff. So before COBOL was created, and especially before the concept of compilers was widely used, every time a new computer came out, you had to write everything again in machine language. And once compilers were introduced, and including therefore the COBOL compiler, you could suddenly write a program once and not have to keep changing. You just recompile it for a new platform. Then IBM comes along with the System 360 in 1964, and they made a promise that, likewise with the hardware platform, that once you wrote something, you didn't have to keep rewriting it because whatever worked on a 1964 System 360 would continue to run into the future, and that's true today. Although there's certainly some very important reasons why it's worth recompiling just to take advantage of the latest technology. Now, when I say COBOL comprises hundreds of billions of lines of application code worldwide, you know, it's sort of the Carl Sagan movie, you know, billions and billions. Well, you know, it's not just the stars out there, it's COBOL lines of code. That just the vast amount of code, it really is the language that runs the world economy. And it works so well. You know, somebody once said housework is something nobody notices unless you don't do it. Well, you know, legacy computing, if you want to call it that, is the same way. It works so well, we forget. It's still out there running everything. And so, you know, a response rate of 92% of organizations saying, you know, that this is a strategic language. And here's the other thing, because COBOL really is the original open project because it was not created for any one vendor or even one platform. It was created independent of any platform with leadership such as people, such as Dr. Grace Hopper and other key people contributing to creating a language without reference to which platform. And then, you know, basically 4 or 5 years later, along came the IBM mainframe. And one of the cool things that happened is that the IBM mainframe was designed along the same principles of doing business. And so the two just kind of clicked. So just thinking briefly, what would the world be like without COBOL? Well, you know, first of all, you would have to strip it out from every global region because it's running key business everywhere in the world, every major industry, basically every big business, especially big businesses that have been around for a few decades, and at least tens of thousands, probably more like millions of applications and hundreds of billions of lines of code, all of that stuff is currently running the world economy. And if you were to turn it all off right now, the world economy would essentially cease functioning. And the issue is that you can't just rewrite it. It is stuff that is developed with all of the various business rules, all of the principles, everything that each business has that were developed over time. And in many cases, were part of how the business ran before computing. And it's implicit in that. And to take the high performing, that's the other thing. COBOL performs very well doing exactly the kind of thing it was designed for. And moving to any other language, you get no advantage and a lot of disadvantages for no reason, because COBOL is out there and it's working right now. As it turns out, a lot of people when COBOL came out didn't care. COBOL was first started to be developed by Codicil back in 1959. It was GA in 1960. And very shortly afterwards, its detractors were already quite vocal. And so we have one anonymous detractor, lost to history while COBOL is still alive and well, said, it is rather unlikely that COBOL will be around by the end of the decade. What's interesting is a lot of the technology created in the 1960s, that's what people were thinking, it'll be good for this decade. But it was done so well that it just kept running, and it ceased to be something that had a horizon in the future. We simply have no reason to believe that COBOL is ever going to go away in this current timeline of human history. So, we had another thing in 2020 when the beginning of the pandemic happened, where media were saying, oh, we should just cut ties with COBOL. People are holding up unemployment checks. And, we've got this ancient computer language. Well, it turned out, in fact, that they just weren't investing in current hardware. And the language was actually perfectly flexible for being adapted and changed to do more things. But it's just we're looking for a scapegoat, and COBOL seems like an easy one, but it is not a sustainable scapegoat because it's the one that just keeps working. With all that said, basically in May 2020, a working group under the Open Mainframe project was created, the COBOL working group led by Dr. Cameron Say, and it was intended to provide ways for which people can acquire COBOL skills, to have a group of people who are key contributors in the industry to be talking about, looking for ways to get the word out, to ascertain what the word is, what is really the case, quantify how much COBOL is really out there, and then publish that information and really start to get the word out. It's sort of interesting to think that, back 1959, 1960, the Codicil group that created COBOL and had ownership of it had the job of getting the word out about COBOL. And then for, all these decades later, basically, 60 plus years, COBOL has been around, and we're just taking it for granted, and we're just rediscovering that, what, the world needs to find out about this, because there's so many bad decisions being made by people who don't even know the COBOL and the mainframe exist, when both of them are critical to the world economy. And so our group was, focused on COBOL, not on the mainframe, but recognizing obviously that so much of the COBOL does run on the mainframe, to really take our experience. And I'll give you a list of our group members towards the end of this presentation. I'll bring up a website with an article that you can look at yourself. But basically, so we did a survey to understand the size of the COBOL market and really find out what people think are the big issues and concerns in this market today. How are companies addressing these issues? And then follow up with from the basic responses with phone interviews to clarify and understand, and use that to create a going forward plan as we really try to get the word about COBOL out in the world. And, this is a critical time, in case you've ever wondered, when's the tipping point for the mainframe, other than when it was first announced? And let's be clear, the mainframe was first announced in 1964, and IBM invested like $5 billion back then in it. Likewise, COBOL was announced, in 1960, and the word came out and people tried to work on it. For all of the 1960s, both of them really took off, and then by the 1970s, they're being taken for granted. And by now, it's like people just don't even know or care they exist. But it's time to wake up to the fact that both of them exist because of their important role. And so it's really important to use that information to get that word out. So we did the survey, and then we started digging into data. We got a lot of really good data. And one of the first things we found from just a small response sample, I'll consider a good number of people, but not a vast number, was that there are billions and billions of lines of COBOL out there that are still in active use. And it really, the most current data shows it's hundreds of billions. One of the big issues was skills, which is funny because COBOL as a language was actually created to require as few skills as possible. We forget when COBOL was created, there wasn't really such a thing as a computer programmer. And COBOL was created for accountants and secretaries and administrators to be able to write COBOL. So it was actually a language designed for people who weren't programmers. So the skills question is really not as much of a skills question as you think, because many of the original COBOL programmers were brought in from other lines of work and just taught at work how to do it. There is some geographical disparity in usage of COBOL. And so what I'm going to do now is flip over to an article that is based on the findings here. And let me include pasting the URL of this article into our chat for our presentation here. So that can be shared with everybody. So basically, I was given the opportunity to write about our survey and the history of COBOL and that sort of thing. So I put this article together to talk about that. One of the things the article gives more exactly is the names of the various people who are involved with COBOL. So we have, again, Dr. Cameron Say, who is our leader. We have Len Santalucia, who is probably the most connected mainframer on Earth. It's like, if you were to do a survey of every mainframer on Earth and who are the high-profile people that are connected to, I'm pretty sure that Len Santalucia's name would be at the very top. An amazing person, just super involved in keeping the whole world of mainframe and the world of COBOL moving forward. Now, Derek Britton has a particular special role because he's one of the people at Micro Focus. And Micro Focus is sort of the place where all non-mainframe COBOL kind of collects together. It's not the only place that has COBOL other than IBM, but those are the two big places where you're going to find COBOL. So Derek has a key role in the world of COBOL from a non-IBM mainframe perspective. And so he contributed a great deal. Phil Teplitsky, which is a fellow who's got just a deep, profound role in the history of legacy computing and COBOL and mainframe and such. In fact, I had the pleasure of interviewing a number of these people here on a podcast I do that's on Tech Channel, including Phil. Gagan Kakar, who has a deep role of history of the mainframe working on that, and Misty Decker, who had basically about just shy of 30 years on IBM, and then moved over to work with Derek in Micro Focus. And so we have these folks that really we came together and talked about, what is the state of COBOL? What do we need to know about COBOL? What do we need to communicate about COBOL? And how do we do that? So basically, one of the things that really we concluded from the language that originally started from CODISIL, the Conference or Committee on Data Systems Languages, was that this language is very much alive and well. And some of the things that came from our survey were that basically 70 to 80% of all business transactions worldwide are written in COBOL today. Now, I hope that made you just fall off your chair, because you think about it, every time you use your credit card, every time you do any business transaction of any kind, the odds are very high that there's a mainframe involved somewhere. Even if you're doing that transaction to somebody who doesn't have a typical mainframe, there still is a mainframe or COBOL somewhere back there that they have to go through in order to deal with it and to make it happen. There's 60 million patients cared for daily using COBOL programs. And one of the things to keep in mind here is every computer programming language has at least one sweet spot, one area that it's really good for. C, for example, has a number of sweet spots, but they tend to be very technical. Fortran, it was really good for math. We got Python, which is really great for a lot of modern programming. But the sweet spot of COBOL has always been business-oriented activity, which is all the stuff we used to do before we had computers by hand. All those manual calculations, business calculations, logistical, all those things that were done using decimal math and characters are COBOL's sweet spot more than any other language. And so we see 95% of all telemachine transactions processed using COBOL. 96% of all vacation days booked involve COBOL. That's sort of the interesting history of the reservation systems. The Social Security Administration alone has 60 million lines of COBOL code. The IRS has 50 million lines of COBOL code. And that's just a drop in the bucket compared to the hundreds of billions of lines out there. So basically what it comes down to then is having gone out there and reached out, surveyed to understand the market, the size of it, the nature of its usage, and what the issues are, that certainly it was a case that there is massive continued use of COBOL. And the largest organizations on earth are not only still using it, but they're not going to move off of it by and large, first of all, because they can't, whether or not they realize it. But second of all, because there's just no value to it. There is no technology out there that will give you more than Cobalt already gives you. The only reason you even try is because somehow you don't like Cobalt. But over time, you can get used to it because it works. It's used for fundamental applications. And the only issue is staffing. And so because of the need to get a new generation in Cobalt, that's really the thing we're all putting our shoulders to the grindstone on now, is to keep working to get the word out, to get new people into the world of COBOL programming, and recognizing that being a COBOL programmer is actually really a straightforward thing to do. You could learn on the job and become proficient enough to be maintaining business applications much faster than, for example, getting a computer science degree, because it was designed to be a language that effectively is self-documenting. I've written a lot of articles about COBOL myself. You can Google them up. And one of them, I basically assert that by the time you finish writing the variables for a COBOL program, it practically writes itself. And so that said, here are the steps we're going to take moving forward. We're going to complete analysis of the data further and move forward, getting the word out. So that's sort of just a quick summary of what the COBOL working group has done so far. And at this point, I've got about 6 minutes left here. Maybe I'll open the floor for any discussions or comments or questions.
This is awesome. Thank you so much, Reg, for sharing what, the COBOL working group. And I know through even your article and on a slide earlier, you touched upon skills, and, that's something comes up quite often since 2020, even more so, which I remember very clearly, and Paul Newton would attest. We had started working on the COBOL programming course, the content of it at least, right? And like you mentioned, the pandemic hit, and there was absolute frenzy about COBOL skills and COBOL being, the bottleneck, and those unemployment checks going out and all of that. But right there in the midst of all of that, in April 14th, to the date, I remember it, we landed the COBOL programming course as an open mainframe project. And Mike, wasn't it like over 100,000 views of the COBOL course or something in that first month or something like that? It was beyond believable. It was unbelievable.
It was awesome. It was awesome to see, even though, I think, as you mentioned, COBOL was somewhat in the news as a scapegoat. It drove a lot of traffic to our course. And what was also interesting about that is a lot of learners invested their time and energy into taking the course, registering and going through the hands-on activities on the platform. So certainly, as far as the skills shortage, we saw folks at least enthusiastic and interested in learning the technology. And one nice thing we were able to achieve with the course is we built it a lot on open source tooling. So they were able to use tools they may have already been familiar with, like Visual Studio Code technologies like command line interfaces, when working with the platform, with the mainframe. And then just being able to focus on learning the specifics of the language.
Yeah, exactly. And I think the course addresses that skills issue, right, Reg? That the survey and in general, the perception that we have around, there might be some value or truth to it. What I also want to point out is we have right here on this call, we have a Hurtanto, we have a Sainath, we have these young next generation technologists who are looking at COBOL, who are learning COBOL. And so I think the future is bright. It's safe to say that. But yes, thank you so much for sharing these results and the work that the team has been doing. And, Mike mentioned working on some of the modern and the interface and the tooling. Right there comes in Zoe as well, right? That's one of the key components of the COBOL programming course too. So I think in a way, it's bringing all of these projects together within that open mainframe project umbrella. I'm just so glad that you were able to share your experience and thoughts here, and look forward to our further working together between the course and the working group, because I think there is a lot of synergy for us to do a lot of good and go on the crusade, COBOL crusade, as you put it, together. Anyone else have any?
Yeah, so I was going to make a comment and I would love for Reg's take on this. So the COBOL of old, the COBOL is a standard, and the standard has evolved significantly. In fact, we at IBM with Enterprise COBOL are trying to live up to today's current standard. And one thing that I'd mention, when we put this together, I knew that we needed to have a chapter on intrinsic functions. And one thing about today's COBOL that's very different than the COBOL from decades ago is these intrinsic functions. And so COBOL has become modern. Many times you would have to code things a long time ago that today intrinsic functions can do for you. And so the number of intrinsic functions is growing, and it's the best place to start to figure out the power of COBOL. So I was just going to get Reg's comment on the COBOL of old versus COBOL today, specifically as it related to intrinsic functions.
And just briefly, because I have to duck out in a minute, but one of the things, the beautiful things about COBOL is if you learn COBOL, 60 years ago, that skill set would still be relevant today. But as you point out, today's COBOL is so vastly, elaborated beyond that in so important ways, and on the one hand, some of those ways are basically generic COBOL, some of those are, custom. And so you think about, for example, the ability to do vector decimal math that maps to the IBM hardware. You think about things such as the ability to do Java or JSON rather, or XML, just all this incredible range of things that allow you to just do it one step. Well, as you point out, could have taken a long, long time in the past. COBOL really, if you're looking to get excited about a language, every other language out there is sort of percolated up from the community, and COBOL has always been, something that's been designed to meet a need that as that need changes, COBOL keeps keeping up with it. And so, yeah, just I guess the best thing I can give you is enthusiasm. It's just a spectacular thing. That said, I apologize. I have to duck out for another call, but thank you so much for the opportunity. I wish you all well.
Thank you so much. Thanks so much, Reg. Really appreciate you sharing, and we'll catch up and talk soon again.
Sounds good.
All right, so Sainath, I'm going to come straight to you and get your thoughts, really. You heard Reg talking about COBOL and the, how pervasive it is, and it is still live and kicking. And you've been our summer mentee as well, right? For this summer mentorship project with Open Mainframe project. So let's get your thoughts on what you heard, what you worked on with COBOL. Just really want to hear what you had to take away.
I felt that COBOL is a well-structured, simple to learn, and a powerful programming language. Initially, it felt very easy actually, but after a while, I thought that we can improve the course in a better way. Asking user for the more input into the project and making them learn even better. We can improve the experience of the users while also learning. And I feel like COBOL is a legendary language, and it is the backbone of the financial industry, and many businesses use this. I also read somewhere that NASA also uses COBOL, and there is and in mainframes, mostly the widely used language is COBOL. And yeah, it's a legendary language and it can't be replaced. Yeah.
So I think you put it very well. It can't be replaced, but that discussion does come up oftentimes, right? But so from your working, and I think, correct me if I'm wrong, Sainath, you did have to take the course as well, right? Because you're working on adding chapters to it. And I think one of the project pieces was, Reg also mentioned, bringing in JSON and XML. So what was something that jumped at you as COBOL as a programming course? What is it, what strikes to you as it being different? And out of curiosity, what other programming languages do you know or have you learned through your undergrad degree that you're pursuing right now?
I learned Python, JavaScript, and many more. CPP, Dart, Flutter. Yeah.
That's a long list. So if you were to think about COBOL and what you've learned over the summer, how does COBOL stand out, or what differentiates COBOL, and where do you see, and why do you Why do you think your comment of it can't be replaced
Yeah.
would be true? You know, I guess that's what I'm trying to understand.
Yeah, actually, the language I learned, and this is totally different because COBOL is a compiled programming language. Implementations are usually compilers. Yeah, and it's mostly used to on mainframes. But if we compare rather other languages like JavaScript or Python, it is more interpreted programming language. Yeah, which implements directly. It executes the instructions. Yeah, in in the JavaScript and in Python, it's actually you like you create a variable or generate anything, but this COBOL is totally a different language. Yeah, we like can't.
So Sainath actually captured a few things there that I'll elaborate on. And as he said, comparing it, he said it really gets down at the machine level because you can't compile Java or Java. Well, you compile it, but it runs as bytecode. It doesn't write, it doesn't really execute at the machine level. COBOL is extremely fast. And people that say, I'm going to take this COBOL application and put it in Java, it'll never be as fast in Java. It's nearly impossible. And so he brought up a number of things there that resonated with me. He got it, that every language has a fit for purpose. And some younger people fail to understand that. And that's the biggest problem. To be an expert at many languages means you know what language to use where. And Sainath just started to point that out there without going into great detail about it.
That's a very good point. Yeah.
The difference here is the sorting methods and many other.
Yeah.
And one thing that I've always argued is that if COBOL didn't exist and the business got together and decided we need a computer language for business, we would probably invent COBOL. You know, today, we would probably invent COBOL because it is the original rules-based engine for business and still is to this day. And as Reg pointed out, it's unparalleled in financial mathematics on the mainframe. Nothing can do financial mathematics like COBOL on the mainframe. It hands down. And as Tack pointed out when we started this, I loved his comment when we started this. And Tack, being a computer science professor and good with a lot of different languages and first exposed to COBOL, he immediately realized that computer language shouldn't be a fashion statement. And I love that comment. It was so right on. He had never seen COBOL before, but then he realized what was going on. He says, computer languages should never be a fashion statement. I thought that was awesome.
Yep, exactly. Yep. We kicked off our COBOL programming course launch with Professor Tack, opening with that statement. The very famous programming languages are not a fashion statement. Anyone else? Any thoughts to share or, you know, ask Sainath any questions from his experience as a mentee with COBOL? Hartanto?
Yeah. Oh, I have a question. Sorry, I know you didn't call me out. Hartanto, did you want to go first? I'm happy to wait.
I was just going to give a round of applause to Hartanto because Hartanto is Sainath's mentor for the Summer Mentorship.
Oh, wow.
Yeah.
Awesome.
So we have two young COBOLers here on the call, if I might point that out. But go ahead, Joe.
No, yeah, good job, Hartanto. Yeah, so one of the things, and I'd be interested to see your feedback on. So I programmed a lot in Java, and I do a little bit of JavaScript and TypeScript, but less than I used to now. A lot of those languages, I was having this discussion with someone the other day. He said, well, about 80% of your program is written by somebody else. And sometimes the, you know, you go and you're having import statements, include statements, you know, even Python, you have these online registries like NPM and PyPy and things like that, Gradle, Maven Central. So you're hoovering up a lot of code, and sometimes the art is to actually end up writing a very small program that's just wiring together other programs, almost like the way you build a microservice architecture, but it's not done with network connectivity. It's done with everything being bound. So everything's got scope to the rest of the program. Whereas COBOL doesn't. COBOL is what you see is what you compile, right? There's very little between you and the metal. You can call other programs, and those programs can do things for you, and you can pass data and get results. And my question is whether you see that as a fundamental difference, because that has ramifications, especially for like security. If you're using a package manager based language and you're pulling in lots of modules written by other people, I've seen, the Log4j vulnerabilities, which was an accidental defect. Sometimes you get malicious defects that people put out there. You get all sorts of things. Whereas sometimes that's something about the financial world that they like that level of trust, which is just, it's what they compiled. They have it's very sandboxed. Anyway, I wonder if you can talk to that, whether you see a fundamental, because I feel fundamental difference on package manager languages versus non-package manager. It's a real.
I could start by making a comment, Joe. I mean, I can code in Java, but I never trusted it because just of that fact. And the reason is I could write a piece of code, it could start, and if it got really important and it started failing, they would come to me and say, well, it's not really my code, it's all the other baggage that's there that had a problem, and I don't know what to do. So it made me feel really nervous being an old-fashioned type of developer where I like to understand everything end to end. Like I wanted control. With Java, I don't have control. And so that's the thing that bothers me. And I'll let the younger ones speak to some of that.
Yeah, don't be shy. Hartanto, you can go off mute too.
I'll add some commentary to there. That concept is that, with package managers and also all these languages, leveraging package managers, I think overall it's good because it keeps folks from sort of, I would say, reinventing the wheel in a lot of cases, being able to do rapid development. I'd say it's very, very, very important to have structured tools and processes to ensure you're not having a security vulnerability or anything like that. Things like software bills of material, checking attestations and things like that to ensure you're actually getting what you think you are getting. And then also being able to manage runtime environments like Log4j. So if you were managing the code you pulled in and ran at your site, you'd have a clear view of what was running and how to update it. But to the point of COBOL, or not being a package manager, there was still a community around COBOL where folks would collaborate and discuss best practices for developing programs. So I don't think we missed out there. And I think a lot of this is overcome to some degree by the intrinsic functions that Paul was mentioning. Like if we can expand the intrinsic functions, there might be less that I need to import from some third-party library, and that's just built into the language. I think there's a lot of momentum around intrinsic functions, making it there be less of a need to solve some of these challenges. But certainly it is, I would think it would have a negative impact if folks were rapidly developing new COBOL programs to not have a registry they could pull already established software from. But a lot of these large companies that have been around for 40, 50, 60 years and are the backbone of the financial industry, I think they have a lot of internally built up libraries that they're sharing sort of as what we would refer to now as inner source, right? Within their company. It's not available on a public registry, but they make it available maybe in the form of copybooks or things like that. So a lot to cover there. There's advantages and disadvantages, but I think intrinsic functions help close the gap there.
Yeah, to me, the intrinsic functions really is helping make COBOL modern. And one thing that a term that I just learned the other day when we were talking about Java and JavaScript and these other things, these other higher level languages that sometimes are bytecode or interpretive, is I just learned about this thing called OWASP the other day. Now, this thing called OWASP stands for Open Web Application Security Project. And it's a big deal, and there's a lot behind it. COBOL didn't create the need for OWASP. It's all the other stuff that did. And just learned about that the other day, and it's bigger than a breadbasket to try to cover up some of these issues with things like Java and JavaScript and others. And like I say, COBOL didn't create this situation making OWASP necessary. These other languages did.
Yeah, I'd say that's true, but I'd also say that, you know, it's not a consequence of necessarily the language. It's the consequence of deciding to leverage other folks' software for rapid development. That paradigm just never really took off or existed on the mainframe, mostly because, as we've talked about, COBOL was used within institutions and as proprietary software. So there's not much, you know, I'd say, I think you sort of captured it well earlier when you said, or maybe it was Reg that said, a lot of software is built out of the community collaborating and building up ideas, where COBOL was more built for a particular purpose.
Mm-hmm. All right, so Sainath, just coming back to you, I know Joe wanted to hear your thoughts as well on, you know, the package managers, the philosophy of having package managers in a language versus, you know, where and how COBOL is. So definitely do share your thoughts on that. But also what I wanted to ask you was, you've done COBOL now for about 3 months, taking the COBOL programming course. What is the one thing that you really think is a key differentiator or a feature about COBOL that you absolutely love about the programming language that you wish the other languages that you're already used to and work with would have had or have? So
yeah, my favorite aspects of COBOL are, it is simple to read and debug. You can easily check around the code and debug. And it is widely used on mainframes, and it proves the dependency across the platforms. Yeah.
Okay.
Yeah.
So, Hartanto, any thoughts on that same question? Because you're another young mainframer and you've been doing COBOL for maybe a little over a year now. You've been one of our key committers and contributors to the project. Any thoughts on that?
The package manager question. So I think Mike really summed up my opinion on the package manager question. But one thing that I noticed while leading up a few months ago is that we now have user-defined functions for COBOL on the mainframe, which is a new thing. And might be useful to basically share the function between people. And well, if you ask me about features that I want other programming language to have, is really the readability of COBOL. It's easy to read. I can just pull up a code now and basically understand what it does. And I believe that Rex said earlier that it was designed for accountant and people with business laws to basically be able to understand the program. And I think it's something which you are unable to see in other programming language that are much newer and more commonly taught in schools.
All right, but both of you had a similar thread, the readability and how it's simple as a key feature of COBOL that you both really enjoy. So that's interesting, isn't it? At least to me, that the ease of understanding the logic of the program, the readability is something what youngsters are looking for. All right. Any other thoughts or questions for our guest speaker here today? No? All right. If not, I will say thank you everyone so much for being here with us for our 3Q quarterly webinar call. And Sainath, thank you so much for being a summer mentee on this project and working with our awesome mentor, Hartanto here, and really bringing that next level of improvement to the course. I know you talked about improving the course in terms of usability and user experience, looking forward to that because we are looking forward to releasing that next version of the course. So good work there, and keep us posted, and we'll publish that next revision out for the community of learners. All right?
Yeah.
Thanks, everyone. Have a wonderful rest of your day. Bye.
Thanks. Bye.
Thank you.
Cheers.